Hey guys, so now that you know the basic integrating du over u, and when you have a fraction, you try to make u the bottom and your du should, maybe be the numerator. You try that. We're going to look at ones that involve trig. So we never integrated tangent before. We only knew how to integrate sine, cosine, secant squared, cosecant squared, secant x tangent x, and cosecant x cotangent x. We never integrated just straight up tangent or secant or cotangent or cosecant. So I'm going to show you how to do that. So obviously you can't do anything right now. You don't have a formula for this. So what you can do is change this into sine over cosine. And now this is when we bring our u into this. So now that it's a fraction, what are you going to try to make u? Right, cosine. And your derivative of cosine is negative sine. So the sine is already in there. That's how you know you're in the right track. So what do you need to put in? You need to put in a negative and multiply by a negative on the outside. And you end up getting negative the integral of du is the numerator, u is the denominator, and we just learned that du over u integrates to negative natural log of the absolute value of u plus c, and then the last step is to plug your u back in, which in this case is cosine. So I want you to notice something. This is just a formula that you need to know. So whenever you're trying to integrate cosine, the formula is negative natural log of the absolute value of cosine x plus c. I have everything listed below here. So this integrals of the 6 basic trig functions. The ones you already knew. You knew sine and cosine also. But here are the 4 new ones. The integral of tangent is negative natural log of the absolute value of cosine. So once you realize that, you have a formula for it. Like, for example, k. Once you see that you're integrating tangent, you say to yourself, well, I have a formula for that. But what's my new inside? My new inside, since it's something other than x, you're going to make u that inside, which is 5x. And du would be 5 dx. And so you're going to put a 5 in and multiply by 1/5 on the outside. You need a 5 in there to complete your du. So you're left with 1/5, the integral of tangent u du. And that integrates to negative, and then you're going to put the 1/5 in there, the natural log of the absolute value of cosine of u, so I'm going to put my u in, which is 5x, plus c. All right, so once you realize you have a formula for it, ask yourself, is your inside something other than x? It is, it's 5x. So you're going to make u 5x and go from there. We're not going to do L, all right, because we're not going to waste time when we have formulas. You can find the integral of cotangent the same way we found the integral of tangent, but you would turn it into cosine over sine and go that way. But we're going to jump right to the example. So look at M here, okay? And we have a formula down here for cotangent. So since you have a formula, you say to yourself, all right, I know the integral of cotangent. My inside is 3x, so that's what I'm going to make u. Okay, so what would du be? Yep, 3 dx. So you have to put in a 3. Doesn't matter where you put it. I usually put it in the front. Multiply by 1/3 on the outside. Get 1/3 the integral of cotangent of u. The u replaces the 3x. The 3 dx gets replaced by du. And this integrates, go down here, to the natural log of the absolute value of sine. So this turns into 1/3 the natural log of the absolute value of sine of u, which I'm going to plug it in, which is 3x, plus c. All right, so it's really simple. that you have with having a formula sheet right now. All right, and I'm going to skip n. I'm not going to derive how secant comes from. It goes into this whole long thing. To get the formula for the integral secant, you actually multiply by secant x plus tangent x on the top and the bottom. I know I said I wasn't going to go into this, and now I'm doing it. And then you distribute on the top. It ends up being a du over u problem. That's how you get this formula right here. So we have a formula for it. We're going to go right to O. All right, you're going to say to yourself, I know how to integrate secant. My inside is 2x, so that's my u. My du would be 2 dx. Got to put a 2 in. A 1/2 on the outside. This is 1/2 the integral of secant of u du. And based on our formula down here, secant of u integrates to the natural log of the absolute value of secant of u, which is 2x, plus tangent of u, which is 2x, plus c. Okay, I'm literally just copying down the formula right here. Okay, once I pick my u and I put in what I need and reciprocate on the outside, then I just go right to the formula. All right, you can only put in numbers. You cannot put in variables or other trig functions. That means you picked the wrong u if that's the case. All right. Okay, so some of this stuff stayed. Let me erase it. Bear with me. Okay, so, all right, we're going to just continue. Sorry, I hit the pause button. All right, we're going to continue with this. Part P, since you have a formula for integrating cosecant right here, what are you going to make u? Right, root x. And I told you that it's easy to memorize the derivative of root x because that comes up a lot. Derivative of root x is 1 over 2 root x dx. And you already have that in here. This is technically 1 over root x dx. You need the 2 on the bottom. So you put a 2 on the bottom, which is really like putting in a half. And that means you got to multiply it by 2 on the outside. So this ends up being cosecant of u du. All right, and cosecant of u integrates to negative natural log of the absolute value of cosecant of u, plug your u back in, plus cotangent of u, which is root x, plus c. And there's your answer for part A. All right, next one. What do you want to try u here as? Right, make it the whole denominator, so 2 plus sine x. The derivative, or du, is cosine x. We don't even need to put anything in. All right, look at that. It's already in there. So this turns into straight up du over u, which, learning from day one, that integrates to the natural log of the absolute value of u plus c, and we plug our u back in. So the natural log of the absolute value of u, which is 2 plus sine x, plus c. All right, now looking at r, okay, the main thing you should see in here is secant tangent. Secant tangent. Yes, we have a formula for that. The integral secant u, tangent u is secant u. But our inside is something other than just x. We got to pick our u as the inside. Our u would be 3x cubed. What's our du? Maybe derivative 3x squared dx. You know you're in the right shape, or going in the right direction, or in good shape is what I wanted to say, is when you have your du mostly in there, except for maybe a number. Look, I have the x squared dx in there, I need to put in a 3 to complete my du and multiply by a third on the outside. And that ends up being secant u tangent u. And the rest of it, the 3x squared dx, is my du. And this integrates to secant u. So this is 1/3 secant of u, which is x cubed plus c. Right? Like I said, you're going to refer to the formula sheet. It's a lot easier when you have a formula sheet. Looking at S, and I gave it away here, notice that the degree is bigger on the top for S. The degree is bigger on the top. So when the degree is the same or the degree is bigger on top, what did I say that you had to use to integrate this first? You have to long divide first. So let's go through this. So we're dividing x minus 2 into x squared minus 2x plus 1. All right, this is how you long divide, because I know you guys, some of you still have questions. What times x gives me x squared? X times x gives me x squared. So I'm going to write that underneath. I also have to take this x and multiply it with the -2. I can't ignore that. So that would be -2x. When you draw a line, you change the signs because you're subtracting. And now this ends up being 0. This is 0. You're left with 1. You can't divide a variable into a constant. So your remainder is the 1 over what you're dividing by, so x minus 2. So what you did was you long divided to write this in a different format so that you can now integrate. This is an x. And you're going to integrate each part separately. All right, both of these really have a dx in it. So to integrate x, you get x squared over 2. When you integrate, and it has a dx in it, when you integrate 1 over x minus 2 times dx, this goes back to the fact that it is a fraction, and you make u the denominator, and your du would be just dx. So when you integrate this, this is just du over u. Because the dx is in the top, that's your du, and your u is in the bottom, and that integrates to the natural log of the absolute value of u, which we're going to plug our u back in, which is x minus 2 plus c. So this whole thing, I'm going to cover that, is your answer. So when do you long divide again? When the degree is bigger on the top or the degrees are the same. All right, so for t, okay, this is an older problem. If you have a denominator and it has a root in it, or it's raised to a power, do not make u the whole thing. Make u just the inside. You don't want to be dealing with powers and stuff when you go to derive to get your du. So what would we try to make u here? Just the inside, x cubed plus 1. Du would be 3x squared dx. So you know you're on the right track because there's an x squared in here. So I need to just put in a 3. And if I put in a 3, what goes on the outside? Yep, 1/3. So watch out. This is 1/3 the integral of du, not over u, over the square root of u. That does not turn into the natural log. Only du over u, the first, turns into the natural log. So to integrate this, you have to bring it up and make it to the -1/2 power. And that integrates to, just be careful with your rules, you add 1 to the power. So when I add 1 to a half, I get, or when I add 1 to -1/2, I get a half. I'm already thinking ahead. And instead of dividing by, I multiply by what? and multiply by the reciprocal, which is 2. So this ends up being 2/3 u to the 1/2. So I'm going to put it back in a root. You don't have to. You can leave it to the 1/2. I'm going to put my u back in, plus c. And there you go. All right. The next one here, move this down. Right, you don't want to leave cosine squared on the bottom. And these are some of the identities that I'll give you on the quiz and that I gave you before. You want to rewrite this. 1 over cosine squared is equal to secant squared. Why am I rewriting that? Because you don't have a formula up here to integrate 1 over cosine squared. You know how to integrate secant squared. Look at this. Secant squared is equal to tangent of u. So you're going to rewrite it as secant squared, and now you're going to pick your u from here. What would your u be? 3x. And my du is 3 dx. So I put in a 3 because I need it for my du, and I multiply by 1/3 on the outside. This integrates to secant squared u du. And based on your formula above, that turns into tangent of u, which is 3x plus c. All right. And V and W are old problems. They were on your 4.5 quiz and they were on your chapter test, but I wanted to go over them again. These do not look exactly like any of these formulas up here. Okay, we have cosecant cotangent up here. It's not cosecant to a power like it is down there. Same thing with the last one. These are not raised to a power, so it's not exactly like that. What does it mean when it's not exactly like one of the formulas up there? It means that you have to think bigger in terms of your u. A suggestion would be, if you have one trig function raised to a power, try to make u that trig function and see if it works. Well, the derivative of cosecant is negative cosecant, keep your inside 2x, cotangent, keep the inside 2x, dx, times the derivative of the inside, which is times 2. Now, you're looking in here in the problem saying, did I pick the right u? Is everything in there? Well, look, cotangent 2x dx, that's here. You have enough cosecants. You have 3 of them. So what you're going to do is you're going to borrow one, and you're going to make this cosecant squared 2x. And then you're going to write the other cosecant, I'm going to run out of room, right next to the cotangent. So basically your du is right here, but you still need to put in the -2. So that's no problem. I'm going to put in the -2. And that means, what do I multiply by on the outside? -1/2. So this is -1/2 the integral of this right here. That's u to the 2nd power. The rest of it that's underlined is my du. So I integrate this. It becomes u to the 3rd over 3 plus c. So that's what, -1/6 u, which is cosecant to the 3rd 2x plus c. And there's your answer right there. Now, for W, okay, our very last one. This looks similar to the last one because it involves cosecant and cotangent. It's not one of the formulas up above because these are raised to power. So now you got to think, is my u going to be cotangent or is my u going to be cosecant? Now, if you know your derivatives, which I will give you these formulas, you know that the derivative of cotangent is negative cosecant squared. So you should be picking u as cotangent because the derivative of cotangent is negative cosecant squared 4x times 4, because you're doing a little chain rule there. And look, that's already in there except for what? Except for the negative 4. So you need to put a negative 4 in, and that means you need to multiply by negative 1/4 on the outside to compensate. So what we have here is negative 1/4, the integral of, all right, this underlined in blue, that's my du. Du always goes on the end. The rest of it, the cotangent to the fifth 4x, cotangent's u, so this be u to the fifth then. And that integrates to u to the sixth over 6 plus c. So that is negative 1/24 u to the 6th. So I'm going to plug my u back in, which is cotangent to the 6th 4x plus c. And there's your final answer there. I want you guys to know that writing it this way versus writing it like this, cotangent 4x, the whole thing to the 6th, it means the same thing. It's just personal preference, so don't let that confuse you if you see written either way. All right, so that's the end of the 5.2 notes day 2.